be in a Cartesian integration. But when you're integrating polar, you're doing arc lengths, right? The origin. The origin. The enemy's gate is down. The origin, the center, right? So it didn't define a bottom for you, right? So we don't use the x-axis anymore. The x-axis is just a ray in polar land. So when it says find the area inside the cardioid from 0 to 2 pi, one great step might be to try to figure out what this looks like to begin with. Did you graph what this looks like? Looks like a lima bean, right? So when you set up this integral, though, what was it going to be? 1/2 what? Integral from what to what? 0 to 2 pi of 1 plus theta squared d theta, right? And it looks like this, right? The cardioid looks like. And did we get the integral right? Yes. I think so. Now you square it out, and then there's one piece of that that's annoying to integrate. What's the one piece that's annoying to integrate? The cosine squared, yeah. If you had a calculator, use your calculator. There's no glory in doing it by hand. What do you have to use to do to integrate cosine squared? Parts. It's annoying. Do we really want to do it? No. You've done it before. But the point is the setup. This is what it's really important that you be able to do right here. And it's really important also that you remember that this is what it looks like right there. That's what the cardioid looks like for 1 plus cosine. Okay, the next one was 35, I think. 35? This one? Did you graph these? What are they? What are they? They're circles. How do you prove they're circles? And when I say prove, usually it means go back to Cartesian. How do you prove, for example, that r equals 2 cosine theta is a circle? What do you do?
Express x and y in terms of theta.
Yeah, so what do I do here? Anybody, what's one concrete step I could do algebraically? What could I do? How do I turn this into the equation of a circle? What do I do? Square it? Okay, so I get r squared is equal to 4 cosine squared theta. What is r squared? What do I do? That's not in Cartesian. I'm asking you effectively, how do I convert this to Cartesian coordinates?
Wouldn't you just use the x?
Hold on, one at a time. What'd you say?
Wouldn't you use y equals...
Oh, we know y is equal to r what?
Sine.
Sine theta. And we know that x is equal to what?
R cosine theta.
R cosine theta, right? Correct?
Yeah.
Is that correct?
Yeah.
So yeah, we'll get tan too. We also know x squared plus y squared is equal to r squared, right? So there are a lot of different directions to go in. What one concrete step do you want to take now? We're trying to convert this to Cartesian, everybody. What do you want to do?
Set r equal to y over sine theta.
Set r equal to y over sine theta? We could do that, okay. R equals, so you want to do y over sine theta squared is equal to 4 cosine squared theta? Is that what you meant? That seems like it might hurt us.
Yeah.
So let's try again. Anything?
Plugging in r.
Plugging in r from where? I need complete.
Plugging in r as 2 cosine theta into...
Ah, okay, so you want to plug r as the 2 cosine theta into what?
Into the r and the...
Sure, I like that idea. So plug it in there and also plug it in there. Sure, let's see what happens. I like that idea. So what does y equal?
2 cosine theta sine theta.
2 cosine theta sine theta. And what does x equal?
2 cosine theta cosine theta.
Cosine theta cosine theta?
Yeah.
Okay. Does that help us?
You can find tan by...
No, we don't want tan. Stop talking about tangent. Don't want tangent involved in this. That gets us somewhere. Now, that was algebraically okay, but does that get us anywhere helpful? Doesn't look like it. Doesn't look like that gets us anywhere helpful. Any other guesses? That's a good try, but where do we want? Let's keep on trying here. Any ideas?
Oh, wait.
Any ideas?
You put 2...
So you could square it first. That was one thing we did before, right? Cosine squared theta. But what does r squared equal? So we have x squared plus what? Equals 4 cosine squared what? Theta, correct?
Yeah.
But we need to get that theta out of there, right? How do we do that?
4 cosine squared theta. We can express kind of x.
What is this? Does this help us at all?
Yeah.
What does that help us at all?
Oh yeah.
Plug this one right here
Yeah. Yeah.
for x.
Plug r into that.
Plug r equals this one into this one.
Yeah.
Okay, we could do that. So what does that equal? So we know that if we plug, to see what he's saying is plug r into there. So what does that mean x is equal to? 2 what? 2 cosine theta, right? It's pieces of it, but we didn't do the other part of it. We're going in circles here. So what does x equal? 2 what? Cosine squared theta? Do you agree with that? So what does 2x equal? 4 cosine squared theta. So where do you plug that in now? Into the right-hand side, and what do you get? X squared plus y squared is equal to what? 2x. So x squared minus 2x plus y squared is equal to 0. Can you complete the square on that? What do you add to both sides? 1. So you get x squared minus 2x plus 1 plus y squared is equal to 1. So what is it? X minus 1 squared plus y squared is equal to what? 1. There it is. That is a perfectly valid question that you might get hit with on a test. Absolutely. Yes?
Could you know that r equals 2 cosine theta?
What do you want to do? Which one? Which one? Start at the beginning of your sentence.
R equals the one in the blue box right there.
There are 2 blue boxes.
R equals 2
This
cosine
one?
theta.
Okay, yep. What about that one?
If you made cosine theta equal to r over 2.
Yes, okay, so you said cosine theta is equal to what?
R over 2.
R over 2. Okay, then what?
Plug that back into
To where?
the blue box on the right.
Okay, so you want to plug that into the this blue box?
Yeah.
So what do you get here? X is equal to what? R times what?
R over 2.
R over what?
Over 2.
Exactly, very good. So what do you get? 2x is equal to? But what does r squared equal?
4 cosine
No,
squared.
x squared plus y squared. That's an identity.
Oh.
There it is, you see? So are we now back to where we worked pretty hard to get to quicker? Absolutely. Are there lots of options? Yes. Just because you take an option doesn't mean the algebra is improper. You might run into a wall. Okay, reevaluate, keep trying. A lot of these will pop together. So basically, we just showed that is a circle of radius 1 with center at 1, 0. That's all I wanted us to do. So what does this look like when you graph it? It's 2 circles, right? So what's the quick way to do this one right here? What's the quick way? We use, instead of this one, we use this one, right? What does sine equal? What does sine theta equal? Y over r? Y over r, correct? Do you agree with that? So then, where do we plug that in? We plug it into right there. And what do we get? R is equal to what? 2 times y over r. Right? So what does r squared equal? 2y. But what does, but that's therefore equal to x squared plus y squared. So what does that come out to be? X squared plus y minus 1 squared is equal to 1. The center's at -1, 0. Different center. Similar work. So what do you get? You get a picture that looks like this. Are you comfortable with that picture? Are you comfortable with that picture? So it's asking for this area right here. Do you see symmetry? Yes. Yeah. So you can either do it from 0 to pi over 4 or pi over 4 to what? And double it. Which one do you think I would choose? 0 to pi over 4 or pi over 4 to pi over 2? Which one do you think I would choose?
0 to pi
Why?
over 4.
Why? Why? 0. Just say, cause 0. Whenever we have a choice of using zeros, that's usually the path of least resistance. So what are we talking about? We're talking about this function right here, that one, if we go from 0 to pi over 4. So it's going to be 2 times what? What's the integral going to be? 1/2 from pi over 4 of which function? 2 sine theta squared d theta. Is this something you're going to want to do by hand? Are you going to want to do it by hand? No. Could you do it by hand? Yes. If you had your calculator, do it using your calculator. Does that make sense, everybody? You could do pi over, it's similar. You could do the other one. Okay. How about, and you wanted 40 what? 44? Was it 44 was the last one? Okay, this one right here. Did someone ask about 44?
Yeah.
That's fine. So it says find the arc length of the curves, the arc lengths. Do you remember what the formula was for arc length?
Yeah.
What was it? It was alpha to beta of what? The square root of what? Yeah, dx d theta. Yeah, and what was the caveat to this? What was like the key thing you had to watch out for?
For the right alpha and beta.
Alpha and beta, and also what tended to happen to the radicand, the thing underneath it? It tends to be not cool. It's doable, but it's not cool. Remember you plugged it into your calculator and it was just hard enough like plugging in the freaking numbers, right? Yeah, exactly. So here's the thing though. They say r is equal to 1 over theta. What do we have to find first if we're going to do this? X and y. So we know that x is equal to r cosine theta. So what does that mean x is going to be? 1 over theta cosine theta, right? So that's the same as what? Cosine theta over theta. So what is y going to be? Sine theta over what? Theta. So what do you have to find? Dx d theta. So what rule do we have to use? Yeah, low d high minus high d low all over what? Low squared. And what does dy dx equal? dy d theta, sorry. Low d high minus high d low all over low squared. And then you have to, it tells you actually, it's kind of nice, it tells you the alpha and beta. So b is, and a is pi. Yeah, go ahead.
They don't tell you how you figure it out.
You have to look at what they give you. So if they say, for example, a common thing would be like, here's a graph, here's one petal. What's the area or arc length around a petal? But then you have to analyze like what it is. It's not always obvious. Did you do 15 for this homework assignment? Okay, before we do 15, you didn't ask if we're going to do it anyway. On this one, if you had to find the arc length on this, what do you then do? What's the next thing you do? You take this and where do you put it? You take this and where do you put it? And if you did it by hand, you hope to high heaven that it simplifies nicely. Because if it doesn't, you're kind of stuck, right? You hope that there's like cosine squared plus sine squared is 1. Yes?
Actually, I think we can skip the quotient.
We can skip the quotient rule? You want to use the product rule?
Proved that yesterday.
Yes. What is it?
Square root of f theta squared and f prime theta squared.
Yeah, so it was a homework problem from yesterday, right? I think it was 45.
Right.
So there was something, yeah, what Stephen is referring to is this. In this case, we know that f theta was what? 1 over theta, right? So you could do it this way if you had this. So we could do it this way. If you want to, if we do this, what's f prime going to be? Negative theta to the what? Negative 2. So what do you end up with? 0, what was it, pi over what? Pi to 2 pi? Pi to 2 pi of the square root of theta to the negative 4 plus what? Theta to the negative 2 d theta. That's not bad. Is that better to write down? Yes. Question to you is, can you do that by hand? No. Technically, maybe. Do you want to do that one by hand?
No, I'd rather not.
But at least here's the big at least. At least that's easier to write. Was this a lot? Not that much more work, right? Either one. It's good to know both. Okay, let's look at 35. Can we look at 35? Is that okay? Or 15? So on this one, it says graph the equations, and there are 2 loops. For each loop, give a restriction on the theta that shows the loops, that shows just one loop. Go to the board, everybody, please. Go to the board. Find a partner, a new partner. Everybody, you have to be really careful with this. What I liked, I saw the proper algebra people. The petals are rooted at the origin. So everything was based on this. 0 equals 1 minus 2 sine theta. And when you did that, you got theta is equal to pi over 4, right? You need to unfreeze it? Yeah, I do. Pi over 4, right? And then the other one, next one would be 5 pi over 4, correct? So the first arc, the blue arc, this blue arc, I agree with you. It is pi over 4 all the way to what? 5 pi over 4. Do you agree? Okay, so the green arc, what's the lowest one for the green arc? 5 pi over 4 all the way to what?
0.
All the way to 0? All the way to what? All the way to pi. Yes, you have to be really careful with this. You can't really say, if you're gonna, I understand what you're saying, but if you're progressing forward, like you go from pi over 4 to 5 pi over 4, right? So you're going from this to what?
9 pi over 4.
To 9 pi over 4? Is that enough? Is that enough?
Forgot to count for first loop.
You have to be really careful. I'm just asking you, is that enough? Let's see what the answer key says. The answer key says something interesting. I don't think did I paste it in?
No.
I don't know if I did. So if I plug 9 pi over 4 in, 9 pi over 4, what degree measure is 9 pi over 4?
45. Oh, 3.
9 pi over 4.
That would be 405.
Also, it's out of the restriction basically. Because it says from 0 to 45.
Is it 45 degrees?
Yeah.
Okay, that's fine. So is this enough? I'm just asking. I'm just wanting to stand by. Is it enough? Yeah, I'm just trying to get you to say there's different ways to do it. Yes, go ahead.
Is there any way that you can...
It starts here at the origin, right? So what does this thing do? At theta value 0, it starts here, and then what does it do? It travels to here, right?
Yeah.
And then what does it do?
It
Goes up. It goes up and around like this.
Yeah.
And then what does it do?
It goes finish.
Does it go down?
Go to the left.
It goes to the left. It goes. So then it goes this way, right?
Yeah.
And it goes all the way around like this. It goes all the way around. Do you see that, everybody? You see what I mean? It bounces. Yeah, go ahead.
Drawing like this should be...
Different reasons. Here's one of them. What about this integral makes it improper? What specifically about this integral makes it improper?
Infinity.
The infinity, right? So how do we set it up? We set it up as a limit. So we say limit. What letter do you want to use, Chip? Yeah, b to infinity of what?
The integral from 1 to b.
Of x to the negative 2 dx. Yay. Solve that for me. Do it right now. On your own. It's either going to blow up or not. So if you do this out, you actually need to do the integration. So what's it going to be? The limit as b goes to infinity of what? What's it integrate to? From 1 to b, right? Just to make things easier on yourself. 1, yeah. That'll change it drastically. Just to make your negative life easier, what can you do with that negative sign? Put it on the outside. Do this, please. Just put it out. So what do you end up with? Negative limit as b goes to infinity of 1 over b minus what? 1 over what? 1 over 1? Is that correct? What happens to this thing as b goes to infinity? So you end up with negative 1 is 1. Careful with those negatives. Yes?
Can we take out the negative and change it from b to 1?
Can you take out the negative? Say that again.
In the rule section, can we take out the negative and change it from going to b to 1?
Oh, you mean like flip it around?
Yeah.
Yes, you could if you wanted to. So are there other types of things that make things improper? Absolutely. I could ask you this, and what's the issue here? What's the issue here? There's no infinity, but it's still improper. What's the problem, Chip?
It can't be 2.
Yeah, 2 is not what? How do you say 2 is not in the... It's not in the domain of the function. So can you tell me what the limit I need to set up is? Can somebody who hasn't spoken yet, can you tell me what the limit needs to be? Soma. Okay. There's one thing that's missing that's really important. It's not approaching 2. It's approaching 2 from the left. From the left, because it's 0 to 2. That's really important. Going to 2 implies both directions, which we can't do on this. You're not integrating to the right. So try this one now. See if you can give me an answer to this one. So when you integrate this, you end up with a limit as b to 2 from the left of what? Negative x minus 2 to the, from 0 to b, correct? Yeah. So what is that? Negative limit as b goes to 2 from the left of 1 over b minus 2 minus what? 1 minus 1 over 0 minus 2, like that. So what happens to this right here? What happens to that? 2 from the left is smaller than 2. 2 is greater than it. You subtract it, you get a really, really small negative number. So what does this go to? Negative infinity. So you end up with negative infinity plus a half. Yeah, that half is along for the ride. What does that mean? Boom. My hyper-articulate way of saying it does not converge. It blows up. Okay, integral you have, Nam.
I got limit of b to 0 from the right.
Limit of b to 0 from the what?
The left.
From the left of what?
Negative 1 to b.
1
over x.
Mm-hmm.
Yeah.
Plus what?
Plus limit of c.
Great. You changed letters. Thank you. From what? Sorry. C?
C to 2.
Yes, of x to the negative 4th dx.
Should
C, not infinity. What am I doing? 0 from the right. I'm sorry. Right. There we go. Try number 3. You have to break it into 2, and you have to do 2 limits. You have to approach 0 from the left, and you approach 0 from the right. Could you solve this? Solve it. Finish it for me. Oh, wait. It's 2.